Hello everyone, welcome to this video. Today we're going to learn how to use the FOTRIC standalone acoustic camera. The idea is that you grab your unit and we do this step by step along as you watch the video. Feel free to stop at any point as I'm going to be showing how to do it. Now, not all the points are going to be covered on this video, so I always recommend you to take a look at the written user manual. So let's start. Alright, so for starters, we need to make sure that the camera is fully charged before we start. To replace the battery, all we need to do is to press the front and back button and pull it out and bring the next one. We need to make sure to push it all the way until we hear the click. Alright, now we also want to make sure that the camera feels comfortable to use. For that, it is important that we pass our hand all the way to make sure that the knuckles are past the hand strap. Make sure that you open, adjust to the size of your hand, and make it tight and comfortable. As an additional measure, you can put your hand through the wrist string just to make sure that nothing bad is going to happen. For left-hand users, you can also use the additional accessory that comes with the camera. All we need to do is to use the tool over here to place the screw, and it is recommended that this part, this little slot, is facing upwards, as I show right here. That way you can remove the hand strap from the other side, from this part, and then put it on the other side. So let's learn how to use the interface of the camera. First of all, we have the drop-down menu for quick access to some common features, like adjusting the brightness of the screen or turning on the flashlights of the camera. The camera comes with two flashlights in the front, especially for leak detection in dark environments. I can also activate or deactivate the flashlights by pressing this button. Once again, just by pressing, goes on and off. Now, we have a leak simulator on the back of the room to try to demonstrate different parts of the interface. So let's take a look. So here we have an emitter of ultrasound frequencies. There are also two more emitters, part of which emit also audible sound. You might hear it in the background. Now, I can see a signal that is occurring right here. I'm going to start by switching the mode. This is just the most simple and very basic mode, the one in the middle, which is for leak detection. On this mode, we're able to locate where a leak might be without giving a further assessment of it. I can see that the camera has detected that source as a location of a potential leak, and that the camera switch and adjusted the range from 10 to 50 kilohertz. If I were to go back to a different one, for instance partial discharge, it will jump from 20 to 60 on the default mode. What we see on the right side is the frequency filter, which allows me to visualize specific frequencies versus others. If I want to ignore this specific sound source, I can see that there is a high peak around 40 kilohertz. That's an indicator that the frequency with the highest amplitude or highest intensity is around 40 kilohertz. If I want to remove that from the screen because it belongs to a source that I already know but not the problem that I'm trying to find, I can adjust the level and then that source will disappear from the screen. I can also narrow around very specific frequency bands by adjusting the span. As you can see, I can manually adjust the span. I can also go to one of the presets, like the audible sound, which can be detected for that particular source, and then the ultrasound. Any of these frequency ranges or bands that I want to use and that I know that are going to work for my specific application can also be saved. To do that, I will go to the main menu, Settings, Acoustic Camera Device Set, and on the frequency configuration, I will toggle that on. Going back, after adjusting the specific frequency range that I'm interested in, let's say this one, so that I find this type of problem but not that one, I will tap here, and now I have a plus button. I'll tap it. I will call it, let's say, New, and save it. Now I have a fourth preset that goes only from 46 to 60 kilohertz. So I can go around default and then jump to the frequency that will show the problems that I'm familiar with. Now, in certain applications, I'm interested in knowing not only the frequencies and that have predominant presence on my scene, but also the value in decibels of those sources. Remember that those sources can be leaks, can be mechanical problems, or it can also be partial discharge. So I will go to the settings. Then I will move to acoustic device set, and I will turn on the show dB value or show decibels value. After turning that on, you will see that the camera is showing me the decibels value of that specific source, which is around 38. However, if I modify my range and bring it back to the source that was on top of the suitcase, the hard case, I'm ignoring by frequencies this source. Now I'm showing only this one, and I can see that the intensity is higher. It is 90. This source is more intense than the one that is next to it. It is common that when we start using the acoustic camera, we encounter situations like this, or like this, where we see colors all over the place. This commonly happens when I haven't configured properly the frequencies of the specific issues that I want to deal with. Right now, my camera is showing me a map of frequencies based on intensities. The colors will indicate the level of intensity or sound pressure level of different sources, showing me that there are two main sources on the screen. But if I were to adjust that frequency to a higher one, now we see that the original source disappears, and in this specific frequency range, I am showing the highest intensity of the entire scene on the second source, even though it is only 30 decibels. A common approach to identify problems in different environments, whether I'm identifying leaks or partial discharge, is to start by using the specific frequency range that I'm interested in, let's say this one over here, and then change the visualization mode. I can see the name of each icon by moving on with the directional buttons. The signal source mode can be single, multiple, or hologram. Once again, the hologram is a map of intensities on a given bandwidth of frequencies. I recommend to start with a multiple mode. The multiple mode will show different sources that are close to the highest intensity source given in a given frequency band. So right now I can identify 1, 2, and 3, even though previously I was seeing only one of them. This mode is good to identify multiple sources of problems in a general scan. The recommendation is that we scan around and identify for reflection. Not all the sources on the screen are problems. Some of them might be reflections of those problems. When starting an inspection in search for leaks or partial discharge, it's common to see scenes like these ones with multiple sources and especially shifting sources on the screen. You might also encounter situations like when the hologram mode is activated, where it's hard to understand where the problems are located. So let's start by going to multiple mode. I see 3 sources and I want to identify which ones they are. Currently, I'm using the default mode for leaks. Let's go and switch, for instance, for the one that I previously preset. Now I have a specific 1, 2, and 3 different sources on the screen for that frequency range. A good way to identify a true source versus a reflection that can occur with surfaces around it is by changing the angle and walking with the camera. You will see that some of the apparent sources are shifting in position, appearing and disappearing, while the true source remain on the screen. You can see now that if I go to previous bandwidth, there's some reflection on the desk and also over there on the surface. So it is always recommended that you walk with the camera and try to identify those sources that remain in position. Another way to isolate and estimate each specific source is by using the focus ring. The focus ring size can be changed in the acoustic camera device set. Let's start with the large one. When activated, the focus ring will show a specific area of interest. This mode or this ring works best when I'm doing single mode. Remember that the single mode will only show the signal with the highest intensity on the screen. So I have this source and I can isolate it so that I can take the picture. But before we do that, if I shift to a different location, instead of having two sources, I have that other single one. You can notice that only one of them are present on the screen. What happens if I change my frequency range to the specific source of problem over there? Now the only one that will appear is that specific one. Let's say that two sources are very close to each other. I can change the acoustic camera device settings and then switch from large to medium or even small. Now that the focus ring is smaller, if I have similar frequencies, I can clearly separate them one by one. I can also use the different modes, let's say partial discharge, to analyze that source versus this another source, or use it as leak detection mode to calculate an estimate of that leak. Let's see how to visualize different things on the screen. I will go back and turn off the focus ring. I would also like to show you how those different modes can be easily accessed from the shortcut button AI. If I tap right here, I will have to choose one by one. But I can also press and hold the AI button to do that specifically for me. So I will switch to sound source mode, hit enter, and after pressing the button, the camera will start switching from single to multiple to hologram. That way I can start with multiple, identify general, do a general scan, identify multiple sources, eliminate potential sources of reflection, and then go back to single to work on a specific one. I can also set up other types of shortcuts over here by pressing and holding the button. I can also enhance the visualization of a given problem by changing the palettes. I can go to this icon over here. There are three main palettes that pretty much will just change the color that I'm seeing on the screen. In addition to those three, I can tap on the three dots and I can have that the digital camera switches to a palette of gray. After doing this, you will see different ways of visualization. If you are in an environment, manufacturing environment, it is common to have a wide array of colors and multiple components. A gray palette will enhance the ability for you to detect specific issues and not missing them. Another way to enhance the visualization of problems identified by the camera is by adjusting the range in the hologram mode. When I'm using the hologram mode, it will automatically go to auto mode. What the camera is doing is measuring the highest intensity on the screen, which is 90 at this point, decibels, and then automatically adjusting to show the other sound pressure levels or amplitudes or intensities of the signals on the screen. If I tap on this area and switch to manual, I can tell the camera how far from the highest intensity value I want the camera to show me. So if I go to a high range, let's say 12, I will be able to pick up signals that are within a range of 90 to 78. The smaller that range is, the more specific that my signal on the screen will be. This is another way to isolate specific signals and remove the visualization of reflection. I can also input a custom value that can go right there manually or even higher. Now, another way to enhance and understand problems and the location of them is by using palettes. Now, the way that I can use the palettes is, let me just go back to single mode. I will go to the fourth icon on the screen, and there are three different colors that I can use to show the location of the problem on the screen. I can also adjust the level of transparency of that signal by tapping enter, and now you see that the signal is even more intense in color and there's no transparency at all. If I go back and adjust that transparency to a lower level, let's say 50%, I can go back and I will see in the back, excuse me, what is behind that source of ultrasound. Going back to the palette, tapping the three dots, I can use a grayscale mode to show the problems on the screen. This is a good way to enter manufacturing facilities that are commonly full of components with many different colors, giving sometimes a difficult time, especially when using multiple mode. I just switch also to 80%, and I'm gonna switch to multiple mode. Now that it's on gray mode, it is even easier to highlight those colors where the problems are located. There are certain occasions where there are specific problems that appear and disappear in a very short period of time. In order to enhance the way to visualize those problems when I'm doing a general scanning, I can go to the settings, acoustic device set. In the measurement enhancement features, I will turn on the TFF-TD feature. That will enable a new set of submenus on the first icon, right here, acoustic parameters, that is on the right side. The TFF-TD would allow me to tell the camera whether I'm dealing with steady sources, like the ones that I've been working with, that's by default, or potential lingering sources, or very short-lived signals, to put it in a way. So I will tap on that one. The signal that is present at the moment still shows. What happens if I change the frequency to part of audible? And then I do this with my fingers. As you see, the signal remains on my hand even though the sound is gone. Even if I'm doing a general inspection and I identify something and I miss it because I'm scanning around, the signal will remain in the screen for a couple seconds. This ensures that you can easily locate problems even if they're not constantly occurring. We just need to make sure that once I have used the feature, I go back to the steady source to prevent false appearance of signals. I'm gonna go back to new, which is the one that I'm looking over there. There are certain circumstances where I have competing leaks or competing partial discharge. That means that there are multiple sources of ultrasound on the on the screen that I want to identify, but because of their different intensities or very close intensities, they will show shifting on the screen, or one will go over the other one, plus the presence of reflection, as it happens and we already explained. A good way to capture an image that provides me with insightful information is by using measurement tools to measure only on the specific sources of problems so that I can save that information for the report or post-analysis. The way to do that is by going on the settings. First, I will make sure that the decibels value is turned off so that it's not showing the decibels value in all the screen. This is just for demonstration purposes to make sure that you understand the use of the measurement tool. Now I will go to measurement enhancements and turn on that specific value. Making sure that it is turned on, when I open the main menu, you will see a new icon on the main interface, in the main menu. By tapping it, you will see the name Measurement Tools. I can add spots or areas. I'm going to add 2 areas. I'm going to locate one of them in one of my sound sources and the other one on the other one. Now that I have those 2, the moment I capture an image, the camera will measure the intensities in decibels of those 2 sources. After pressing the picture taking button again, the image is saved. The same applies if I want to do it, let's say, on a different frequency, the one for the second source. You can see some reflection occurring over here. All I have to do is locate my point, my area in my area of interest. I'm going to eliminate this one by tapping it and deleting it. And now I will capture the image, measuring instantly the intensity of that problem. Now you can see how easy it is to understand which sources are more intense as a result of having a higher level of severity that once again can be friction, a leak, or partial discharge. Okay, now let's talk about partial discharge. Partial discharge is a phenomenon that occurs mostly on an electrical equipment of high voltage. The camera comes with a special mode to detect and analyze so that you not only can locate but also identify the type of partial discharge. To do that, I'm gonna go back to some basic settings. I will change the palette. I don't want gray anymore. I will go back to this one. I also don't need any of the measurement tools at the moment, so I will delete those. Now I will go to partial discharge mode, which is right here. The partial discharge mode will automatically set, usually, a default mode if I haven't set up a specific one that goes from 20 to 60 kilohertz. This is a broad it's a broad frequency range where I can find partial discharge. However, based on your own experience, you can adjust that and set up your own way. Let's say that I want to do it from 30 to 50 kilohertz around. If that's the frequency range that I know that works for my specific problems that I have in my facilities, I will tap right here and save it. So let's say this is my personal PD or partial discharge frequency range. Now, I want to move and identify the little device or sound source that I'm working with today. So I know that that frequency range is a little higher. So I'm going to adjust it, or let's just go to my preset of new. Remember, if you don't see these buttons on this area, you need to go to the settings, acoustic camera device set, frequency configuration and turn it on. If it is off as it is right now, when you come back here, you won't be able to edit any of the presets. Here we are. So now I can see that sound source. You can see that there is a new graph on the screen. This is a PRPD graph. If I tap on it, I'll be able to see the graph on a larger size. The AI on board of the camera is detecting that it's pretty much noise. That's the type of frequency of the problem that I'm emitting with a little demonstration device. Let's see how to set up the camera to show and identify problems and what type of problems they are. When looking for partial discharge, the camera can not only identify the location of the partial discharge, but also what type of partial discharge. There is an AI on board of the camera that identifies, based on the sound source that is picking up, what type of problem it might be identifying. It will also tell you with which level of confidence it can tell whether that is true or not. So let me show you how to do that. We're going to go first and change the detection mode. We're going to go to partial discharge. And it's very important that I set up the proper frequency depending on the power of the given country where I'm doing the inspection. To do that, I will go to acoustic camera device set, then acoustic camera frequency. Some countries work on 60 Hz, some countries work on 50 Hz. For this specific sample device that I'm using, it works on 50 Hz. So I'm going to tap right there. And then the camera will show me in the PRPD graph the type of issue that is identifying. It's a corona effect. And it's telling me that it's 99% certain. There's 99% probabilities that that is indeed that. If you see numbers below that, let's say 60, 40%, you might want to reconsider the approach or the type of problems that you're identifying. You maybe also do a little different adjustments. Now let's see how to use the acoustic camera to give you an estimate of the cost of not repairing a given leak that you have identified. First of all, we will go to the main menu, tap on leak evaluation mode. By default, you will see the focus ring or circle in the center of the screen. Before doing any evaluation and jumping into conclusions, it is important that we go to settings to make this according to the values of my facilities. We will go to the acoustic camera device settings, then we will go to leak evaluation parameters. On leak evaluation parameters, pretty much we're going to leave leak correction factor on 1. This is a factor that can be used later on if I want to do adjustments, if I have a secondary device. The currency that we're using to estimate the cost. The energy cost is going to be the price of kilowatt hour in your specific facilities. Different states have different prices, but a given facility might pay a different lower or higher price. Gas cost will be included when you're dealing with something that is not compressed air. A specific power when working on kilowatts per 100 cubic feet meter should be left by default on 30. Those values can be adjusted, but this is part of a deeper analysis. The flow rate unit, today I'm going to use cubic feet meter, but you can also use liters per minute. And lastly, the runtime. The runtime is pretty much an estimate of how long the compressor is working over a year. So here, for instance, we're giving it a number of running 24/7. With these parameters already set, I will go back to the interface and start scanning. Remember, we would usually go and identify on normal leak the location of the leak. After identifying something that I'm interested in and I want to analyze further, once again we do multiple, definitely there's something in there, then I can go and evaluate it. So I will tap right here, and then I can see a value that is being calculated. The camera is telling me that this leak is 8.3 in level, that is 1.2 cubic feet per minute. Of course, this is not a real leak, this is just a high frequency emitter. And this cost is $540 per year. In other videos, you will see real cases where leaks can cost as high as $10,000, $20,000 per year. In this mode, it's very important that we set up the distance correctly. If I go right here and adjust those values, you will see that the farther the distance, the higher the cost of the leak. In other words, if I'm detecting this level of intensity with the camera at a distance of 65 feet, it indicates that that leak is important enough or big enough to cost about $1,800 per year. So the accuracy of the estimate, remember that this is just an estimate, will also depend primarily on this value. The camera will use the decibels that is picking up from the source, the parameters that I input into the settings, plus the distance. So do not forget to change this value depending on how far you are standing from the leak. Now that you have understood how to identify, locate, and isolate different types of problems during partial discharge or leak detection, we're going to take some pictures. Once identified or located the specific issue, I will capture using the trigger button, the one right here. The image is frozen, and on this interface I can do a few additional improvements or enhancements. I will not be able to adjust the frequency because that was adjusting the microphones when they were live. However, I can still tag it as a favorite so I can quickly find it, especially when I find a problem among multiple pictures that I take. I can also add additional measurement tools or adjust the distance. For this mode I won't be able to add, but distance can be adjusted. I can add voice notes using the integrated microphone and the speaker to later listen to those. It's right there. I can add comments or annotations. I can scan a QR code to capture the data of a given asset or capture the barcode of a leak tag to be able to return back to it and know what's the information of that leak based on the picture that I have taken. And lastly, I can add tags to my specific leak. So let's say this is line 3 of my air compressing system. Once I have done the modifications that I want, I will press the picture taking button once more. And when I go to the gallery, I will be able to see the multiple pictures that I have taken. If I want to filter by favorite, I will see the ones that have been labeled as such. Right now, I didn't have one. If I open one of those and edit it, making it a favorite and saving the change, you will see that picture will appear. If I filter using the funnel icon and I want to see all the pictures that I took of leaks on line 3 of the air compressing system, I will just tap on that line 3 tag, confirm, and only the pictures of line 3 will appear on the screen. Another way of taking pictures is if I'm identifying multiple leaks. Let's say that I want to use the multiple mode right there. I also want to add a couple measurement components or objects. I can now measure those two. Right now, remember that this is reflection, it's not a real one. I will freeze the image right there, and then in this specific interface, I'm able to reposition those elements. If by any chance I had two and I realized that this is a reflection, I can simply select it by tapping on it and then go to the menu and delete it. Once that has been done, additionally, I can also do the same type of inspections or changes on the picture. Let's say switch to single, to multiple, do hologram. In the hologram, adjust the range or the span of signals that I want to show for my specific image. Let's say I want to make it very close to the highest value on the screen, eliminated the reflection. And once my picture is ready, I can hit on the picture taking button again, and the image has been saved. If I go to the gallery, there's nothing because there is a filter in place. I will deactivate it, confirm, and then I have additional pictures. Once that inspection has been completed, I can access the data of the camera using the two sides with interfaces for that purpose. On the left side of the camera, I can open and remove the SD card. By simply pressing on it gently, I can remove that SD card so that I can analyze the pictures or replace for a fresh new SD card that I can use for multiple sites, multiple applications, or different users that are going to use the camera. The SD card can be read with the standard SD card reader that comes with the camera, and then be read by the computer. On the other side of the camera, we have the second set of interfaces. We have first the micro HDMI cable that can be accessed by using the special cable that comes with the camera. Remember, these cables are special, and one that you purchase separately might not have the same performance. The cable will be plugged there, and by doing this, I can export the images on the screen of my camera to a projector or a larger display. Lastly, we have the USB cable for data, which can also be used to access the data on the camera even when the SD card is still plugged. This is a USB-C interface. It can be plugged right here, and we have access to USB 3 protocol speeds, so that I can connect the camera to the computer as well. Once your inspection has been completed, you can turn off the camera. Remember that if you press the power button only once, the screen will be turned off, but the camera is still on. This is just a way to save energy in a way while you're not using the camera. In order to turn off the camera fully, I will press and hold the power button. I can choose from rebooting or simply power off. I hope that this video was informative. Remember that we just covered the most important parts and typical use of the camera. If you want to understand deeper details, if you want to know how to troubleshoot, or perhaps understand the maintenance of the camera, you can still refer to the written user manual. Thank you.